Alright, 11.1 areas of parallelogram. Definition of area is the space inside a figure measured in square units. And what do we mean by square units? Well, let's say I had a little rectangle here, and we'll say this is 3 units and this is 2 units. So there's my 3 units up there, and there's my 2 units here. If I was to kind of just draw a straight line here, straight line down here, straight line down here, when we're talking about square units, we're saying how many little squares of the units that I'm using can I fit in this space. That's all we're really saying. So if this was 3 and this was 2, we could see that we could get 1, 2, 3, 4, 5, 6 into that little space. And so that's the area, right? That's the area. That's how many little square units I could fit into that space. So that's what we're going to do today. We've learned area formulas for rectangles and for squares and for triangles, but today we're going to learn area formulas for parallelograms. A couple things. The base of a parallelogram can be any of the sides, but usually, so it could be any of these sides, but usually we just refer to the bottom side as the base. And remember that if it's a parallelogram, the top and the bottom are the same. And then altitude, another word for altitude is height. And we'll probably actually use this word height more often than we'll use altitude in our area formulas. But it is the segment that is perpendicular to the base from a vertex. So if this is the base, the height is this distance at a right angle from one base to the other end. And usually we draw it as going through a vertex. See? Or here, we have a height right there. It's the dotted line. A lot of times it will be represented by a dotted line. And the area of a parallelogram is actually the same as that of a rectangle. So it's just base times height. So in this first example here, it says find the area of the parallelogram. Well, notice we have a height of 5 and a base of 12. So if I want the area of this parallelogram, all I really have to do is find the base, which is 12, multiply it by 5. And they're each centimeters, so my answer is 60 centimeters squared. And that's really it. So, I want you to try the next 2 problems on your own. Give it a shot. I'll pause the video, and I'll put the answers up in a second to see if you guys got them right. Alright, for practice 1A, you should have seen that the base was 7, the height was 10, so the area is 70 inches squared. For practice 1B, it says given the area, find the missing length. So here you're actually supposed to find this missing length. Well, we know that area equals base times height. We know the area is 24. We know the base is 4. We don't know the height. We divide both sides by 4, and we get that the height has to equal 6 centimeters. Let's go on to the next problem here. This one says find the perimeter and the area of parallelogram TRVW. Well, let's do perimeter first. If this is a parallelogram, opposite sides are congruent. So we know that this is 18 and this is 12. And now all we have to do is add up all the sides. 12 plus 18 is 30, plus another 12 and 18 makes 60. So the perimeter we could find in our head. It's just 60 inches. Alright, that part's easy. In order to find the area, though, we need the base, which we do know is 18, and the height, which we do not know yet, but we could zoom in and find it. Let's do it. If I have a triangle with one angle 60, one angle 90, that means the other angle here is 30. In a 30, 60, 90 triangle, I know that the shorter length is always half of the hypotenuse. We learned that in chapter 7. So that means this is 6 inches. And then I know that the longer side, or the longer leg, is the shorter leg times rad 3. So this is going to be 6 rad 3 inches. And so now I have the height. So since my height is 6 rad 3, I plug that in. 18 times 6 is 108. So my final answer is 108 rad 3 inches squared. There we go. I have both the perimeter and the area. Alright, so I want you guys to try practice number 2 on your own. A couple things you may want to remember, that angles that are right next to each other in a parallelogram are supplementary. So if this is 120, you should be able to find these two angles. Alright, go ahead and give that a shot. I'd pause the video because I'm going to put the answers up in just a second. Okay, so hopefully you got that the perimeter is 42 because 15 plus 15 is 30 and 6 plus 6 is 12, so 30 plus 12 is 42. And then you should have been able to zoom in on this little part over here. You could have done it the same thing on this edge, but I chose to do it over here. And since the other angle was 120, that means this angle must be 60 because 60 plus 120 equals 180. Which makes this angle 30 and this angle 90. So again, I have a 30, 60, 90. And if the hypotenuse is 6, the shorter leg is 3, and the longer leg is 3 rad 3. So that's the height, 3 rad 3. And since I already have the base, 15, I just multiply by 3 rad 3, and I get 45 rad 3 units squared. We should put the units in there when we're talking about measurements like this. So I put a little U there for 42 units and units squared. We don't know what the units are in this problem, so we just put a blank units symbol there. Okay, let's go on to the next page. Alright, the Bushers are planning to recarpet the first floor of their house. Find the amount of carpeting needed to cover the living room, den, and hall. Alright, we only need the living room, the hall, and the den. So what I would do is I would recommend that you find the living room area, find the hall area, and then find the den area. Add those all up, and the total area will be how much carpet you need. I'm going to let you guys try this one on your own because I don't think it's that hard. So go ahead and give it a shot and pause the video and check back for the answers. Okay, so I got living room is 13 by 15, which is 195. The hallway is 5 by 13, which is 65. I got that 5 because up here we see that the base is 30 plus 5. Down here I have 15 and 15, which makes 30. So I just need 5 more for this hallway. So 5 by 13. The den is 9 by 15. So that makes 135. Add these all up, and you get 395. Okay. For this next problem, I think you guys can do this one on your own too. So I'm going to let you guys try it, and then I'll put the answers up in just a second. But really, what you're going to do here is you're going to plot these points and put them on the graph, connect them, make the shape that it is, determine whether it's a square, rectangle, or parallelogram, and then find the area of that thing. So I'm going to let you guys try that on your own first, and then after you pause the video and check out your work, you can unpause it and see what I got. Okay, so if you graph the points, you should have seen that it is definitely a parallelogram. We could prove this by showing that both AB and CD are parallel because they're horizontal, and both AD and BC are parallel because they have a slope of negative 3 over 2, negative 3 over 2. So yes, it is definitely a parallelogram. Now we're going to find the area. Remember that area of a parallelogram just equals base times height. So we have to find the base first. Well, let's just zoom in. We got a graph here, and we can just count 1, 2, 3, 4, 5, 6. So this distance here is 6. Now we just need the height. That's not so hard. 1, 2, 3. Height is 3. So come out the side here, plug in our numbers. Area equals a base of 6 times a height of 3. Area equals 18, and we don't know what units are, so we can just write units squared. There we go. Okay. Last thing I want you guys to do is a summary, and it just says explain in complete sentences why the area formula for a parallelogram is the same as a rectangle. So we learned that parallelogram is just base times height, and a rectangle is the same thing. Why is that? Explain to me why that is. Okay, talk to you later.